Hello everyone. In this video, I'm going to go over lesson 14-2, which is a case study on web scraping. The learner objectives for this lesson include gaining a basic understanding of HTML, understanding the purpose of web scraping, implementing a web scraper using the Beautiful Soup library, and parsing our HTML we scrape from a website using our newly found knowledge of HTML. So let's get started. This section is a high-level overview of HTML, mostly what we're going to need in order to do an example with our web scraper. But I'm sure you're somewhat familiar with HTML, perhaps from what we've learned about Markdown in this class, or maybe from some side projects you've done related to building your own website or your personal website. So HTML is a standard markup language used to create web pages. It's characterized by tags that look like these angle brackets, and they're used to label content. And usually in these tags, you might see attributes to describe the content. So here's an example here for a level 1 section header in HTML, and that header is, this is a header. If this were in Markdown, then this would be a single £, space, this is a header. Here are some basics associated with HTML. I'm going to breeze through these in the video, but I encourage you to read them in detail so that you fully understand. And you can go ahead and pause the video now in order to read through this section. So let's move on. HTML files typically have a header at the top of the file and a trailer at the bottom of the file. The header is going to look a lot different depending on what what style sheets you're using, some different definitions you might have up here, etc. Comments, section headers, paragraphs, unordered lists, images. We're familiar with images from what we learned about in Markdown, because I also showed you how to use HTML in order to specify an image. That way we could set the width specifically, tables, etc. So here's an example. It's a very simple example, just so you can see some of these constructs in action. So personalwebsite.html, this is an HTML file. It's got a header, it's got an unordered list, it's got an image, it's got some more section headers. Here's another unordered list, etc. And here's our trailer down here, just so you can see how this very simple, very clear HTML file is visualized. You can click on personalwebsite.html, the second link, and it'll show you what this looks like. So this is a very simple dummy web page for Butch the Cougar that I made, our WSU mascot, just so you can see those headers, those unordered lists, the images, and how the style sheet makes this slightly more appealing with a different font and the centering. If you want to learn more about HTML, there's a really great Codecademy tutorial called HTML and CSS that I recommend checking out. And also Tutorials Point, HTML is a good one as well. So now we know the basics of HTML that we can use in our web scraping case study. So as we saw in the previous case study about graph mining using Google Maps Distance Matrix API and the Embed API, we can use RESTful APIs to query information from a web surface. Google Maps has servers that listen for HTTP requests and respond to the request accordingly, for example, with the requested web page, file, and/or data. We can also get data by scraping it from web pages. And we do this by fetching the HTML for a web page, and then we parse it on the client side, so that's our laptop side, for example, to extract the information we're looking for. Often programmers will write a script that regularly scrapes several web pages, downloading data and looking for changes and updates. Such a program is often called a web crawler or a web bot. Now, typically the information that a web service wants to expose, they'll have an API in order for programmers to access it. In many cases, the information they put on a website may not be able to be accessible via their API. So programmers will try and scrape this information without going through the API or without going through an API because it doesn't exist. Now, I have this note here because we want to make sure that we're doing this ethically. We want to make sure that we're not scraping any websites we're not supposed to be scraping, or we're not making HTML requests or website requests too frequently so that we're overloading the web services server. So often websites will have a file called robots.txt that specifies some of the rules associated with scraping the site. So for example, WSU's robot.txt, this is wsu.edu/robots.txt, and you can see some very minimal information that they include here in their robots.txt file. And I have a link here to, I believe, the Wikipedia page, so you can learn more about the robot exclusion standard and robots.txt if you're interested. But mostly just make sure that you are ethically scraping and you're not violating any part of the rules that are specified on that server. So now we're ready to dive into the code. We know some basic HTML. We know what a web scraper does. It pulls down HTML and manually processes through it to find some information that it's looking for. So first, let's talk about how we can get the HTML for a web page. The example I'm going to work here, we are going to scrape the WSU Data Analytics web page. This is what the WSU Data Analytics web page looks like currently. So we're going to use the URLlib module to request the HTML of the web page in the same manner we use the module to query the Google Maps API. So we imported here, specify the URL to be the data analytics website. We're going to open this website. We're going to read all of the information from this website, decode it using UTF-8. And then this simple code here is going to display the first n characters of the HTML separated from the last n characters of the HTML by this series of stars, and I've set n to be 200. So I run this. So here's the first 200 characters of the data analytics.wsu.edu HTML, and here is the last 200. So this is the header here, start of the header, and here's our trailer here. Now, we can view this information without writing a web scraper. If we go to the data analytics website and we right click, I'm in Chrome right now, view page source, then we can actually see the HTML in a browser associated with a web page that browser is rendering. So here's our first 200 characters, and here is our last 200 characters down here. Now we would likely want to pull some information from the HTML. As you can tell by looking at the HTML, this is not as straightforward as we would like it to be. A lot of things are encoded in tags and in attributes, so we're needing to know some structure about the HTML in order to manually find something. But we can make the information extraction a little bit easier by storing the HTML elements in a tree structure that we can search and index. And that's where the Beautiful Soup library comes in. Beautiful Soup is a library for parsing text into a tree structure. So for example, here is the tree structure for a standard HTML file. So we have the document, we have our root element, we have our head element, and our body. And each one of our head elements and our body elements have one or more elements themselves, such as our head might have a title. We saw this in the example code for Butch T. Cougar's website. And our body might have one or more, likely many more than one or more tags, such as element. A specifies HTML link. H1 specifies a level 1 section header. So we're going to use Beautiful Soup in order to take our HTML string, one big string of HTML, and specify the tree structure associated with it is HTML5. And then Beautiful Soup is going to create this tree object that we can easily search and query. Here are the instructions here about how to download and install Beautiful Soup. And we also need HTML5lib which is going to define our HTML structure. Once you get these downloaded and installed, then we can write some code that's going to utilize Beautiful Soup and HTML5lib. So I imported here, I make a new Beautiful Soup object for our HTML. This is the same HTML string that I have up here for the WSU Data Analytics website's HTML. So soup now represents our tree structure for the Data Analytics website HTML code. And suppose I want to get the first paragraph in the Data Analytics HTML code. So we could manually search in the HTML string, or we can use our soup structure and just find P. P is the tag associated with a paragraph. So if we just say find, that's going to return the data from the first occurrence. So I print this out right here, print first paragraph, and here is the first paragraph here. Now, if I want all of the paragraphs on the web page, I can use the find all function, find all of the paragraph elements, and have them in a list called all paragraphs. And then I'm going to walk through each paragraph and label it with its position in the file and print it out. So here's paragraph 0, which you can see actually matches, of course, our first paragraph, paragraph 0, 1, 2, 3, and so on and so forth. And note I'm printing out the text field associated with the paragraph. That way we don't get the actual tags on here. So now let's work a complete web scraping example that might be representative of something we would do in a data analytics context. This example is adapted from a book called Data Science from Scratch by Joel Grus. O'Reilly Publishing is a publishing company that lists its published books on their website. So if you click this link here, shop.o'reilly.com. Excuse me. Excuse me. Suppose we want to specifically look at data-related books, so data science, data processing, data mining, etc. Then we would type in data and we would see this website on the O'Reilly webpage. So we can see thumbnails for images, names of those books associated with those images, authors, publishing date, price, what kind of book it is, ebook or a video or let's see. Here's a print book right here. So how this web page is displaying all of these books is it's showing 30 per page, and right now there are 44 pages. So we want to perhaps grab all of these books from all 44 of these pages, just so you can get a sense of what we're going to try and do. Here's our web page, and we're going to be scraping it and then parsing through all of these books that are stored in a table, and there's going to be 44 pages of these books. Each book, ebook, or video listed on the site is stored in a cell in an HTML table. Cells are specified with the TD tags. The specific element class of the table cell for a book, ebook, video is called thumbtext. If we extract all of the table item tags where the attribute class is set to thumbtext elements from the HTML text and count them, it should sum to 30, which is the number of books or ebooks or videos displayed per page. So in this short code snippet here, I'm importing URL lib request so we can fetch the HTML, Beautiful Soup, so we can structure that HTML in a tree. We're going to use the URL that we were just looking at, that web page I just showed you, for all of the data books published by O'Reilly. We're going to build a tree structure from this URL here using my little helper function getSoup. So all GetSoup does is get the HTML associated with our URL and build a beautiful soup object specifying HTML5 as our tree structure. Now I'm going to get all of the table items from our soup such that the class attribute is set to thumbtext. And then I'm going to print out how many of them there are. And we'll see that there are 30 because there are 30 thumbtexts per page. Now we want to only count the paper books and the ebooks, excluding the videos. So each thumbtext class for our table item has a span element tag with the class price label, as in this example here. The text of this is the type of book, a colon, and the price of the book, ebook, or video stored in another span. So for example, I'm going to grab the first book, TDs Sub-Zero. Here's our TDs here. And I'm going to find the span with the attribute class label, class attribute price label. And then I'm going to print out a shortened version of this output. So here's our price label span. We see the first one is an ebook. Here's our colon. And here's our next span, which is the price. So this is an ebook that costs $26.99. Let's go see if we can find that ebook. So here it is, preparing data for analysis with JMP. It's an ebook and it costs $26.99. So this is the first one in our list of 30 on our first page on the O'Reilly shop page. So if we take a closer look at the different types of books, we see that videos only have one price label. So we can find out if a cell stores a video, and we can filter out the videos from our list. So here's a little predicate function that returns true or false if this is in fact a video. If so, we want to exclude them from our list. So we're going to get the price label for the current table item, and we're going to make sure that the number of price labels is 1, and the first price label starts with video. If so, return true. This is a video, otherwise return false. This is not a video. And then we're going to build a new list from our TDs list of only the ebooks and the print books. And let's see how many of our 30 on our first page are actually ebooks or print books, and that is 19. Now the next code here is going to extract from the HTML the title, author, and date of publishing from each one of our ebook or print book table items in our non-vids list. So let's run this. So for example, our first book's info is preparing data for analysis with JMP by Robert Carver, and its date is publishing date is May 2017. And in fact, we did see this example earlier. So now this code is going to extract the book information for all of the data books on the O'Reilly website. And by all data books, I mean for all of the pages. And remember, there are 44 of them. Okay. So the last thing we're going to do here is we are going to count the number of books published each year. So we're going to group all of our books by the year they were published. And then we're going to plot the results and see the trend of books related to data that O'Reilly has published since the first data book. So we're just going to extract the year from our book information, and here's simple matplotlib code that's going to plot the counts for the number of books published that year as a function of the year. So this asterisk here says that this code is in fact running. This will take some time because there is a lot of HTML to scrape and there are a lot of books. So while this is running, I'll go ahead and show you what the output looks like. From a previous time that I ran this. And here is the plot here. So we'll get this plot eventually on our code that I just launched, but we don't want to have to wait for it. So we can definitely see the upward trend associated with databooks, which makes total sense in the world that we're living in. So very cool example, and thank you to Joel Gruss for his example code that we have been using in this lesson on how to scrape the O'Reilly webpage and create this plot showing all of the books related to data published since the early 90s.